This video will cover loss functions in modeling. By the end of this video, you should understand why different people have different preferences over prediction errors from a model, how a loss function expresses preferences over different types of prediction errors from models, and how you should choose a loss function when modeling. All the models we use in data science can be used to make predictions. Information on features will be used to predict the value of a label. But what do we care about with these predictions? Obviously, we want to minimize errors in our predictions. We want the predicted value of a label to be very close to the actual value of the label. But there are many types of prediction errors. How do we commonly characterize errors? There's a paradigm of accuracy versus precision. Accurate forecasts are forecasts that are close to correct. What this means is, on average, the forecasts are close to the true value of the label. In contrast, precision means the error in a forecast is as small as possible. This means that there's low variability in predictions. These are two different concepts, but they're important to think about when generating forecasts. But there are also other attributes of errors that you might care about. Let's think about an example. So suppose you want to build a model that predicts how long it will take you to get to places on the metro. This is actually something that Google Maps and Bing Maps do, predicting transit times. You're going to use this model to decide what time you should leave to meet your friends in Washington, D.C. If you leave when your model tells you to, sometimes you're early and sometimes you're late. Do you care about one type of error more than another? In this case, if you're meeting your friends in DC, if you're early, you're going to get there a little bit early and be by yourself for a bit. If you're late, the same thing happens to your friends. You may care a little bit more about being late than being early, but probably you weight these two types of errors the same. Suppose in contrast, you were using this model to decide what time to leave for a job interview in Washington, D.C. Again, if you leave when the model tells you to, sometimes you might be early, sometimes you might be late. Do you care about one type of error more than the other in this case? Here you definitely do. If you're early for your job interview, you'll get there sometime early. You may sit in the lobby of the building. It'll give you time to collect your thoughts and look over your notes, but it's not that big of a deal to you. If you're late for your job interview, the interviewer will be annoyed. They may cancel your interview, and you probably won't get the job. So in this case, it's pretty clear. You care much more about errors where you're late than errors where you're early. So through the modeling process, you're going to develop models with an effort to minimize prediction errors. But this is complicated by the fact that you might care about one type of error more than another. Just like the examples I just showed you, sometimes you might care more about over versus under prediction. Alternatively, you might care whether or not your model makes infrequent but very large errors versus very frequent but small errors. And what this means is different people who have different preferences over the types of prediction errors models make may have different preferences over which model they think is the best. Modeling requires that we have a way to express whether or not we think a particular prediction is good or not. This way of evaluating prediction errors is going to express our preferences over prediction errors. What does this sound like? It's a lot like a utility function in economics. We'll develop a way to assign a numeric value to the forecasts that come out of a particular model, so we have a concise way to compare one model against another, and we can choose the model that best expresses our preferences over forecast errors. How exactly do we do this? We're going to use a loss function. A loss function is a function that is going to compare forecasts from a model to the actual values. It's going to aggregate all of these forecast errors together into a single number. With loss functions, generally small values of a loss function are going to mean better forecasts. There will be smaller prediction errors. And then we're going to choose the model that minimizes that loss function. So similar to a utility function, the loss function is going to express your preferences over errors. But unlike typical utility functions, large values of the loss function are going to be bad. They'll represent a lot of errors that you don't like. And small values of the loss function are going to be interpreted as good. They're going to represent a model that produces predictions that express your preferences. So in summary, loss functions should reflect your preferences over different types of errors. They're going to place more weight on errors that you dislike more. And forecasting models are going to take that loss function into account and try and minimize errors according to the preferences you express in your loss function. This is going to lead to better decisions because the model that you develop using that loss function will minimize prediction errors according to your preferences. In practice, there are a wide range of loss functions. The most common is mean squared error. Why is that? It's not because mean squared error really embodies some deep preferences that we have over errors from models. It's that the mathematical properties of mean squared error are well understood. This definitely means that mean squared error doesn't always align with your preferences. Again, a loss function is going to express your preferences over different types of errors. This means that different loss functions are appropriate in different situations, and the appropriate loss function depends on your preferences. This means as you move through a modeling process, you should think carefully about the types of errors that you're very concerned about and choose the loss function that expresses your preferences over those types of errors.